Okay, what we are going to do is we are going to do a little video on linear equations with fractions. So if you look at the screen in front of you, there's a linear equation there. The method I would suggest to you to solve these is, first off, you write brackets around the parts of your numerator. So when you're multiplying, you multiply all the bits. Okay, now what I would advise you to do is to make it right so that each side is equal to a single fraction. So here we've got two fractions, we need to make it into a single fraction. How you're going to do that is you're going to multiply the denominator here by the top, the bottom of this one by the top. So you've got 9 times 5x plus 6 times x plus 3. Okay, so that's the top part done. And for the bottom part, you multiply the two denominators together. So we're having 6 times 9. Okay, so when we multiply that out, you get 45x and 6x and 18 all over 54. Tidy it up, you get 51x plus 18 over 54. Okay, so now we have written this side as a single fraction. We haven't done anything to this side yet, so we write down our equal sign and we bring it down. Okay, again, if you imagine brackets around your numerators. So now we have a single fraction equal to a single fraction. What we do is we cross multiply the bases. So my 3 is going to come up and multiply my bracket with the 51x and 18 in it. And my 54 is going to multiply my 2x. So multiply that out and I end up with 153x plus 54 is equal to 108x. So bring my 108 over, so I have 153x, take away 108, x is equal to minus 54. So I swap its side as well. Tidy up, so I get 45x is equal to minus 54. So x is equal to minus 54 over 45. Okay, so again, put brackets around the top parts. So brackets around the separate numerators. Multiply it out so you get a single fraction on each side. So you go bottom by top, bottom by top, bottom by bottom. Tidy it up, let it equal to the other fraction, and then cross multiply the bases. Okay, so that's one example. We do another example, so this one. Again, number, fraction, number. Or sorry, fraction. You want to write this side as a single fraction. So again, start off, write brackets around your numerator parts. You're going to make this as a single fraction, right? So that is the same as 2x over 1 minus your x plus 3 over 4. You cannot simply just extend the 4 underneath, okay? You have to work it out. So we're going 4 times your 2x minus 1 times your x plus 3. So that's base by top, and now for the bottom bit, you're going base by base. So you've got 1 times 4. Multiplying it out, you get 8x minus x minus 3 over 4. Tidying it up, 8x take away x gives you 7x. So you have 7x minus 3 over 4. Bring down the other fraction, so you get 5x over 3. And then you're going to, again, imagine brackets on the top. Cross multiply the bases, so my 3 is going to come up and multiply the bracket with the 7x minus 3. And my 4 is going to go up and multiply the 5x. So we get 21x minus 9 is equal to 20 x. Tidying up, so my 20 will come over and my 9 will go over. So I go 21x minus 20. X is equal to 9. So my x is equal to 9. Okay, so again, straightforward, just follow the steps. If they want to make it nasty to you, they can sometimes make the fractions like little fractions in front of brackets. If they do that, advice would be is make the bottom go underneath the whole top, right? So in this case, it's as simple as writing x plus 4 over 2, right? But for this one, I have to multiply the top by a minus 2. So I get a minus 2x minus 2 over 3. Okay, equals 6. Now to solve it again like before, write brackets around your numerators. We're writing this as a single fraction, so bottom comes up, bottom comes up, bottom by bottom. So we get 3x plus 4 minus 2 to x minus 2 over 2 by 3. Tidying it up, we get 3x and 12 minus 4x and 4 over 6. Okay, tidying up more, 3x take away 4x will give me minus x. 12 and 4 gives me 16 over 6. And that is equal to just plain boring 6. All right, so now we've got a fraction equal what could be technically another fraction. So if you imagine that's over 1. Now we've got the equal sign in between two fractions, so base comes up, base comes up. So we're having 1 times minus x plus 16, so that just stays the same. And 6 times 6, which gives you 36. So we get minus x is equal to 36, take away 16. So minus x is equal to 20. So x is equal to minus 20. Just remember at the end step to make it positive x as your answer. Don't leave it as minus x, so you throw away just a few marks. Okay. Final one we do is this one. All right, this is the example from 2019. It's not an example, it was actual Leaving Cert question from 2019. So again, method, fraction, fraction equals fraction. Start off, write brackets around your numerators. We want this side to be a single fraction, so bases come up and multiply, bases multiply each other. So we go 2 times 3x plus 1, 5 times x minus your 2 over 5 2's. Multiply it out, so you get 6x and 2 and 5x minus 10 over 10. Tidy it up, 5 and 6 gives you 11x. 2 take away 10 gives you minus 8 over 10. So now I have my single fraction for this side. Bring down this one. I get 47 over 10. Right? In this case, what you cop is they are both over 10, so the examiners were nice to you for once. So when the bases are the same, you can just pretend they don't exist. So you can just rewrite it as 11x minus your 8 equal to your 47 and tidy it up. So 11x is equal to 47 plus 8. 47 and 8 is 55. So 11x is 55. X is 55 divided by 11, which is simply 5. Okay, so I hope that helped. So again, method for solving linear equations for fractions. Put brackets around your numerators in case there's any minus signs in the middle. Multiply the bottom by the top, bottom by the top, bottom by bottom to make a single fraction. Get a single fraction equal to another single fraction, and then crisscross the bases. Right, so we're looking at this page and it doesn't really match what I'm telling you, But again, just look over, try a few, and it should work.